Good morning, everybody. So today we're going to talk about rectangles. And again, we're going to put all the markings about the angles and the sides, what's going on with these angles and sides on this rectangle. And on this one, we're going to put all the markings that have to do with the diagonals. So, just like on a parallelogram, because this is also a parallelogram, this side has to be parallel to this side, and this side has to be parallel to this side. Also, on a rectangle, as well as a parallelogram, this side is congruent to this side, and this side is congruent to this side. But the big deal that makes a rectangle when you're looking at the outside part, not the diagonals, the number one thing that makes a rectangle instead of a parallelogram, why the rectangle is a special type of parallelogram, is it has 4 right angles. That's the big one. Now, this angle plus this angle is still supplementary, just like on a parallelogram. It's 180. These two make 180, these two make 180, and because it's a parallelogram, but also because 90 plus 90 is 180. Okay, it's much easier to see on a rectangle than it is on a parallelogram. And that's kind of it for the outside, I do believe. Moving over to this one, dealing with this one, we're dealing with the diagonals. I think from now on the next few pictures I give y'all, I'm going to already have these drawn in. It saved me time too. All right. So the big thing about the diagonals inside of a rectangle to make it special compared to a parallelogram is this diagonal is the same length as this diagonal. And the thing is, because in parallelograms they bisect each other, that means that this parallelogram or this diagonal cuts this diagonal in half. So this piece is the same as this piece. And this diagonal cuts this diagonal in half. But since they're both the same length, that means all 4 of these pieces are the same length. Okay? So if this is 5, this is 5, and this is 10. This is also 10, and that's 5 and 5. Okay? If this is 3, this is 3. This is 6. This is 6. These are 3 and 3. If this is 3x and that's 9, you can solve for x. If this is 2x plus 5 and this is 11, you can solve for x because these two things are the same. All right. Also, with the diagonals in there, we also know something about these angles. Just like yesterday, this angle is the same as this angle, and this angle is the same because they're alternate interior. But the interesting thing is, because this up here at the top, because that's an isosceles triangle, this angle has to be the same as this angle. But since these are alternate interior angles, this angle has to be the same as this angle. And since this is an isosceles triangle, or because these would be alternate interior angles, this angle has to be the same as that angle. So these 4 angles are the same. And the same can be said for these 4 angles. There, 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 and there. All right, so all of those angles are the same. And that's it for that picture. So let's take a look at some problems that you might be faced with, work these out, label them the right way, and get some answers. So ABCD is a rectangle. Again, it doesn't matter where you start. You just got to make sure the next letter you put is B. It goes either here or here. I'll go there, C, and then D. Got to go around in order. ABCD is a rectangle. Angle A is 34 plus 8x. Solve for x. Well, I don't see the diagonals on here, so I'm not going to look at this picture. I look at this picture, and in this corner, I have a right angle. It's 90. That equals 90. That's what I need to do. I need to say 34 plus 8x equals 90. And then I would subtract 34 on both sides. So 8x is 56. Divide both sides by 8, and x equals 7. There it is. All right, the next problem. QRST is a rectangle. QRST is a rectangle. Q to T is 2x plus 4. Q to R is 5x plus 3. And RS is 3x minus 1. What is the measure of segment ST? So this is what we're looking for. We did a problem similar to this yesterday, and it's going to require the same thing to happen. Looking at this picture, again, I don't have the diagonals drawn on this, so I don't need this one, I need this one. Looking at this picture, 3x minus 1 and 2x plus 4, I have 2 dashes, 2 dashes. These two things are the same. We know that. It's a rectangle. Of course, this side's the same as that side, so we just need to do 3x minus 1 equals 2x plus 4. And I would subtract 2x on both sides. So x minus 1 equals 4. And then to get rid of that minus 1, I would add 1 to both sides. So x is 5. That's not our answer. Here, x was 7, because that's what it told us to do. Here, it says, what is the measure of segment ST? Well, I know this segment is the same as this segment. So if this segment's the same as this segment, if I knew how long this was, I'd have my answer. So I could take this, 5x plus 3, but x equals 5. So I plug in 5. 5 times 5 plus 3, that's 25 plus 3, that's 28. That's the answer for that one. All right, moving up. WXYZ is a rectangle whose diagonals intersect at point H. Okay, so I've got to draw the diagonals on this one. Gee, I wonder which picture I'm going to use. All right, there's that one and that one. Ew, I didn't draw that one too good, I'm sorry. All right, WXYZ. I'm going to come over here. X, Y, Z. And they intersect at H. Okay, angle XWY. Let's see where that is. X to W and W to Y. It's this angle right here. This angle right here is 3x plus 2. Okay, that angle is 3x plus 2. Angle XZY. X to Z to Y. That would be this angle right here. X to Z and Z to Y. That would be this angle. This angle is 4x minus 4. What is the measure of angle ZXY? Okay. Z to X and X to Y would be this angle right here. This is our question mark. All right, so what we know this angle and this angle. These two angles, according to my picture up here, there and there would be here and here. They have 1 dot each. These are the same angle. Okay, these are the exact same angles. So if they are the same angle, I can just say that 4x minus 4 equals 3x plus 2. And then I would subtract 3x on both sides. And, oops, pardon me. It's 6:30, almost time to go to duty. There we go. All right. Uh-oh. So down here, I subtract 3x on both sides, so x minus 4 would be left on this side, and 2 would be left on this side. And I'm going to add 4 to both sides, and x is going to equal 6. I'm not done though.
Good morning, Spring High School.
All right, so since we know x is 6, I need to know this angle. Well, here's what I know. I know that this angle, this angle, this angle, and this angle are all the same because it says so right here. This angle, this angle, this angle, and this angle are all the same. So that means that if I knew how much this angle was, since I know this is a rectangle, and in a rectangle, this corner over here is 90 degrees. If I knew how much this angle was, that means I know how much this angle was. And since I know this whole angle is 90, I could take whatever number I get here, subtract it from 90, and that would tell me what this angle is. So since I can plug x in here into 3x plus 2, I get 3 times 6 plus 2, that's 18 plus 2, which is 20. This angle is 20. And if the whole thing, because it's a rectangle, is 90 degrees, well, 90 minus 20 is 70. The answer is 70. Okay, so that was one of the more complicated ones you're going to run into. Just so you know, that will happen. It does happen. It happens on rectangles and it happens on squares. Okay, you're going to see that a lot. Not a lot, but you're going to see it. All right, rectangle, or excuse me, LMNO is a rectangle that intersect at point P. I hate LMNO. I don't know if y'all, if it was this case when you grew up, but my kids, they thought LMNO was one letter of the alphabet. You know, because there's that, you know, H-I-J-K, LMNO, P, and so that was one word, one letter rather. Took them a while to figure out it's 4 different things. LMNO is a rectangle whose diagonals intersect at P. They made a new alphabet song though, and it separates them real good. Let's see, P intersect at point P, and LMNO, doesn't matter where I start, I'm gonna start, let's see, I started there, I started there, same place. I'm gonna start here this time. L, M, N, O. All right, let's see. LP is 2x minus 15. And NP is x plus 5. And we want to know how long it is from M to O. Talk to you in a bit. Let me get this done. All right, so since we know this and this, according to our picture up at the top, this and this are the same, then we can say that this equals this, or in this case up here, down here, we can say that 2x plus 5 equals x plus 5. Whew, thank goodness, because that would not work. Okay, excuse me. It is 2x minus 15. I thought the minus and the 1 were a plus sign. Equals 2x, or excuse me, just x plus 5. Sorry. First thing I would do is subtract x on both sides, so x minus 15 equals 5, and then you add 15 to both sides, and x equals 20. So now that we know x is 20, I can plug it in here, and I can plug it in here. Well, x plus 5 and 2x minus 15, if I plug in 20 for both of those, that one's easy. 20 times 2 is 40, minus 15 is 25. Oh, of course, that and that have to be the same. And the thing is, according to this picture, guys, all 4 of these are the same. So each one of these, if this is 25 and this is 25, this is 25 and that's 25. All of those parts are 25. And if that's 25 and that's 25, from O to M would be 50. So those are the types of problems you're going to deal with when it comes to rectangles. I hope that helps, and good luck to you.